Given the extreme terrestrial issues we have experienced over the recent decade, there is yet another higher factor to consider which, unless addressed, may prove fatal to our species. Originating from our nearest star, coronal mass ejections, CMEs, and their associated geomagnetic storms, with all their beauty and destructive power, although widely studied, are little understood. With the advent of electricity and an ever-growing electrical grid, we humans have experienced a taste of what effects CMEs have on this planet of ours, and although we have limited knowledge of their origin and intention, we do have enough knowledge to prepare our fragile infrastructure against such events. Our necessary reliance upon electricity itself has raised the urgent question: were a significant geomagnetic storm to occur here on Earth, similar to the one experienced in 1859, how would that affect our electricity-dependent economic system today? The beauty of an auroral display, the malfunctioning of satellites, and the damage suffered in our sensitive power grid are doubtless the result of such extraterrestrial influences. And besides the obvious destructive manifestations, might we ask how these unseen cosmic forces manifest themselves in terrestrial phenomenon? How does the surface of the Earth and its atmosphere respond to these unseen forces? How might life resonate with such forces? And can anyone, without asking such questions, so quickly demonize mankind as the main factor in our changing cosmic climate? A cosmic climate which includes the very rain and wind which we so blindly disassociate from our celestial neighbors. Here, we will attempt to elucidate not only the severe problems associated with such events and how we could physically prepare for such a crisis, but what we might learn in preparing for and extending our knowledge beyond an archaic terrestrial-bound environment, shifting our minds to the cosmic environment which subsumes the terrestrial environment. Let us take a quick look at the history of these solar storms. Solar coronal mass ejections, which produce the greatest known threat to Earth, are frequent but presently unpredictable events. The most powerful known storm occurred in 1859 at the beginning of the electrical age. It became known as the Carrington event, after the British amateur astronomer who observed two patches of intensely bright and white light from a group of sunspots near the center of the solar disk. The next day, a powerful geomagnetic storm occurred. American telegraph operators suffered damage to their equipment, and some reported a persisting signal on the line without any current being applied from their batteries. Displays of northern lights were observed at low latitudes, lasting for a full week. Another powerful geomagnetic superstorm was recorded in 1921. At that time, and up until the satellite era, the magnetic activity was associated with solar flares, which referred to the bright light observed in the eyepiece of a solar telescope. The magnetic effects could be detected by the global network of magnetic observatories, which date back to the Göttingen Magnetic Union, founded by Carl Gauss and Wilhelm Weber in 1834. The connection of geomagnetic storms to solar sunspot activity had been recognized since the studies in the 1860s following the Carrington event. But it was not until the 1970s that it was recognized that the coronal mass ejections, rather than the flare itself, were the cause of the geomagnetic storms. Since 1977, a continuous record of X-ray emissions from the solar flares has been recorded by the Earth-orbiting satellites of the GOES system. Coronal mass ejections, which may or may not follow a solar flare, are eruptions of plasma moving charged particles carrying with them a self-generated magnetic field from the solar corona. A large coronal mass ejection can contain 10 billion tons or more of such material traveling at about 1% the speed of light. It is these charged particles, mostly protons and some electrons, which, when aimed at the Earth, produce the ionospheric currents which in turn can induce dangerous currents in the electric power grid. The worst strike in modern times came on March 13, 1989, when currents induced by a coronal mass ejection tripped circuit breakers in the Hydro-Quebec network, leaving 6 million people without electricity for 9 hours up to several days. Experts have described it as largely good fortune that a northeast-wide power outage did not follow. A more powerful CME accompanied by a solar flare occurred in November of 2003, but luckily it was not aimed directly at the Earth. According to experts, a direct hit by a CME of that magnitude would likely have produced a Carrington-level event, but with far worse consequences to a vastly more electricity-dependent planet. In that case, as in some others, the solar storm occurred not in a period of peak activity, but during a period of solar minimum. However, the threat of eruptive activity increases with the onset of the maximum in the 11-year solar cycle. We are now approaching such a maximum in the current solar cycle number 24, which commenced in December of 2008. Let us proceed to develop what consequences might result were we to ignore our celestial reality. The wide-known threat of geomagnetic storms as cited above are just one example of what that reality is capable of inflicting upon an unaware humankind. The threat to the U.S. electric power grid is being largely ignored by President Obama and Congress despite warnings issued by the relevant agencies. Warning events in 1859, 1921, 1989, and 2003 showed the danger that solar activity can pose to electrical power and distribution systems. Now, as we move into another solar maximum, with increased vulnerabilities built into our electrical grid, the danger again looms large. In the worst-case scenario, 130 million Americans could be without power for a year or more. The warnings have been issued, but they have gone unheeded. The greatest danger is to the more than 300 extra high-voltage transformers located at power substations along the routes of major transmission lines. Coronal mass ejections send a powerful flux of charged particles, protons, and electrons into the surrounding space. If the Earth is on a line with that eruption, the charged particles interact with the Earth's radiation belts and geomagnetic field to produce currents in the ionosphere. The power lines which make up the electrical transmission grid act as antennae to couple these ionospheric currents to the installed transformers which step up the voltage for long-distance transmission. The ionospheric or auroral currents produced by a powerful solar storm induce strong fluctuating direct currents in the power lines, known as geomagnetically induced currents, GICs. When they reach the transformers, they piggyback onto the strong alternating current already flowing and cause the iron cores of the transformers to saturate and overheat from hysteresis and reactive resonance effects in the transmission line. This can cause network-wide voltage regulation problems leading to blackouts or complete transformer burnout. The consequences of a transformer failure are catastrophic, as there is a lack of manufacturing capacity for extra high-voltage transformers in the United States and worldwide. According to a study by the Metatech Corporation commissioned under Executive Order 13407 for assessment of vulnerability to geomagnetic storms, manufacturers presently have a backlog of nearly 3 years for all extra high voltage transformers, 230 kilovolts and above. Only one plant exists in the U.S.A. capable of manufacturing a transformer up to 345 kilovolts. There is no manufacturing capability in the U.S.A. for 500 kilovolt and 765 kilovolt transformers, which represent the largest group of at-risk transformers in the U.S. power grid. The 500 and 765 kilovolt transformers are the backbone of that grid that extends into regions that contain nearly 80% of the U.S. population, according to John Kappenman of Storm Analysis Consultants and Metatech Corporation. Thus, as summarized by space physicist Daniel N. Baker, who chaired the National Research Council panel on severe space weather events, and NASA Director of Planetary Sciences James L. Green, writing in the February 2011 Sky and Telescope magazine, large areas of our nation could be without electricity for months or years as power companies struggle to purchase and replace damaged hardware. Because the solar storm threat is greatest to the low-resistance power lines carrying the highest current densities, some of the most vulnerable areas are also those of the highest population concentration. Metatech estimates that more than 130 million people in the U.S.A. are at high risk for such an event. The highest risk areas are the northern states from the Atlantic seaboard to the Mississippi, coastal states from as far south as Georgia, and the northwestern states of Washington, Oregon, and Idaho. A prolonged lack of electricity in any of these areas would reduce the population to a dark age-like condition. Drinking water supply would break down for lack of pumping, and sewage service would soon cease shortly thereafter. For lack of refrigeration, the food chain would collapse and medical supplies would be lost. Fuel could not be pumped, and thus transportation would break down. Heating and air conditioning systems would cease functioning. Communication would be crippled by the lack of electricity, as well as from the direct damage to satellites and sensitive electronics, which a solar storm produces. Perhaps no internet and no cell phones. Modern life would come to a screeching halt, and a population and economic infrastructure unprepared for a return to pre-electricity conditions could descend into chaos. Now, given this ominous reality, there are three means of mitigating the threat of severe geomagnetic storms and electromagnetic pulse damage that are available to us today. 1. Provisions for replacement equipment, including spare transformers and circuit breakers. 2. Low ohmic neutral-to-ground resistors to reduce induced current levels at the transformer. 3. Blocking devices to prevent the flow of geomagnetically induced currents. Some combination of all three measures is urgently required. Maintaining reserve transformers on site, especially near critical metropolitan bottlenecks, is a must. But this would require the restoration of extremely high voltage transformer manufacturing capability in the USA and worldwide. The present backlog in production makes this option unavailable in the short term. Without these measures, the power grid remains vulnerable to a catastrophic failure. Although satellites can provide warning of impending hits to Earth from solar coronal mass ejections, there are no viable options if preventive equipment and replacement transformers are not in place. Shutting down what might be thought to be the most vulnerable points in the grid increases the risk of transformer saturation at other points by increasing the flow of power, in addition to the human and economic cost of a partial blackout in some areas. Also, as noted by Metatech, the expansion of renewable energy greatly increases the threat posed by solar storms. To supply power from wind farms requires the construction of an extensive network of 765 kilovolt transmission lines to bring the power from Midwestern states to the major metropolitan areas of the East and West coasts. In the words of Kappenman, this could result in a sevenfold increase of the existing United States 765 kilovolt transmission network infrastructure, and it would greatly escalate the vulnerability of the U.S. to geomagnetic storms, as higher voltage transformers are more vulnerable. Thanks to a satellite system, we now have sometimes up to a day or two of warning from the time of the eruptive event is witnessed on the sun's surface to the arrival of the charged particle flux, which carries most of the known danger. But, as noted, it is not sufficient to just know it's coming. Preventive devices and backup equipment must be in place to avert a catastrophic consequence. The warnings and required remedial measures reported here were delivered in repeated congressional testimony and compiled in a 2008 report by the National Academy of Sciences entitled Severe Space Weather Events: Understanding Societal and Economic Impacts. In the words of Dr. Baker, the chairman of the commission which produced the report, it is difficult to fathom how damaging an 1859 type event might be in today's world. Yet, so far, no effective action has been taken to implement the necessary defenses. So at least at this point, it should be clear that although we are unprepared, there are means by which the human race can prepare and comprehend such cosmic phenomenon. The implementation of Glass-Steagall and the impeachment of Obama are the first steps to ending the insane, deadly waste of human resources on bailing out Wall Street and the British Empire, and to preparing the human race for cosmic events manifested here on our terrestrial globe. So stay tuned to this website, as Ben Dennison of the LPAC's basement team will be producing a broader study on the implications of such space weather conditions.